I wanted to show off the CNC stepper mount I made for the X-axis. The interesting thing here, as I tore this apart, or after I actually made it, I won an auction on these 10 millimeter ball screws, and I think that's going to fit in there perfectly. And I have to grind this off and make a mount for the back of the cross slide, but I think this is gonna be pretty darn nice. The mount that I made is decent, so I'll just run through quickly how that works. The first thing to note here is I turned down this radius, or this part of the screw, to 8 millimeters, and I fitted a thrust washer on this side, and on the original part here, the other race of the thrust washer is in there. So I'm gonna get the screw started here. So I bored this out to 16 millimeters. Now the problem is that these 4 millimeter bolts on either side, the heads are countersunk. They're counterbored all the way down. And so I actually had to, I don't know if you can see them in there, but I made these standoffs with flats ground in them, so that the head wouldn't interfere with this race here. And they have to be lined up perfectly in order for this to work correctly. But so essentially that race butts up against the thrust washer. And then on the inside here, I made essentially like a cup, and there's another thrust washer race in there as well. So let me tighten this a little bit. I just want to make sure those standoffs for the screws don't move around, because they'll interfere with the race and they can even deform it. Just get these started. Now there's enough play in this that you actually have to adjust this a little bit to make sure it's correctly lined up with the nut in the back here. So anyway, so this cup fits the inner diameter. It's pressed in there, and I may have relieved it. I don't actually remember if I relieved it, but it's pressed in there. I can't actually get it out anymore. This race butts all the way up, and it's a little tight over here because of the original handle, because this is bored out to 6 millimeters. The original handle, trying to keep the dirt out of there. The original handle scores this up pretty bad, so it's a little sticky. Okay, so I've got that, and I've got the rest of the thrust washer here, and then in front of that thrust washer I have a very small 16 millimeter outer diameter, 8 millimeter inner diameter regular old ball bearing. And so these both slide snugly back into the cup. So that seats there. Now the old 15 millimeter part of the screw is going to be pushing this way and against that thrust washer, and against this way you need something to push back the other way, and that's what's going to take out the slop going in and out as you adjust the lead screw. And unfortunately it's not quite long enough for me to situate this like this. I actually have to flip it around. So then I put, this is a 24, no, this is a 48 tooth GT2 belt, and it actually sits proud of this surface here. And the idea that we want is we want to push, we want to use the screw that goes in there. We want to take this screw, and I have another nut on it. We snug this up here. And then we'll actually tighten this nut on there. Not too tight. We just want to create, that might even be a bit too tight. We want to create that pushing, so this whole thing is going to push into the ball bearing, which is going to suck the screw and pinch it in between these 2 points. And that's what's going to give us the rigidity that this particular lathe never had. And now that I actually think about it, there's a washer that needs to go in there. So I can see right now, because I probably don't have the nut threaded in far enough, I've got a whole ton of slop. Thread it in more. You can see how much I can move it in and out. Now this nut has an adjustment on it that's very temperamental. It's not even through the back of that nut, so I got to actually tighten her down quite a bit more. Now once the screw gets through this back nut, it should take up some of the backlash out of the screw because it angles it. There's still a ton of backlash in there. I guess I have to readjust it. I don't know why it's so bad. I can see the thing moving. It's really a nightmare to tighten. So that little turn there seems to have taken all the slop out of it. I mean, that's how sensitive it is. It's pretty unbelievable. And I mean, it's really tight. Let's check it. There's a tiny bit in there, But it's got to have some backlash or it just isn't gonna. The Allen has more backlash than I can measure, but I'm pretty happy with that. So anyway, that's the adjustment that you want to make. So once that's on there the way you like it, the next thing you do is you grab your motor. So I'm going to have to align this pulley a little bit. It's going to have to come back a little bit that way, but that's fairly easy to do after I get these screws in here. So this is the first one that I made. This is like 20% infill, made out of PLA. And because everything's so tight here, to take the backlash out and to get any of the slap out of the gibs, this would actually flex a little bit. And so what I've actually done here is I've integrated into the model a 5mm hole that goes all the way up into this part, and another one that comes all the way down through the bottom there. And I've driven 2 steel shafts through there, and I printed this at 80% infill on PETG. So this should be, it feels about 10 times more stiff. And the only forces this motor is really going to see is it's going to want to do this. It's going to want to flex a little bit out as the belt gets torqued. So that's why I put these pins running through here to try to provide some rigidity going this way. Once this is clamped on, there's really no moving it up like this. All that is gonna be going this way. I haven't tightened this up yet, obviously. And with this other one here, I was able to do threading. I was able to take decent cuts. The lathe, with some of the modifications that I've made to it, has been very, very, it's a different machine, really. Parting, no problem. I don't have any issues parting at this point. There's still some chatter, I think, because of the bearings. But for a small machine, I think it's in really, really good shape as far as its ability to cut. So I'm going to go ahead and put some tension on the belt and then tighten these up. All right, so you can see that this is moving, this is not moving. So the way you can tell if it's no good is you'll hear the belt jumping. You can see it torquing. If I try to go too quick, the whole thing torques over. But I think as long as I keep my speeds on my motor reasonable, it'll be fine. And I can still manual mill. I just got to put this wrench in there. It's a little bit tight for my liking. I haven't adjusted the gibs yet either. But that's it. So you can see these metal studs that are driven in there. If you come around to this side, you can see that it actually comes up halfway. So it's braced down here on the bottom of this flat. That's why this has to go on from the back side. And you know, it's pretty non-invasive to put on. I actually ran this before I did the modification for the thrust bearings on here, and it was able to drive the motor. But there was so much play everywhere in this thing that it wasn't this doing any kind of CNC work on this didn't make any sense, because it just couldn't hold a position. So I hope this is helpful, and if you have any questions, leave them down below. Thanks for watching.